Hello everyone, welcome to BS Explained. In this video, we're going to talk about BACnet tuning policies in N4 platform. Often you have seen commissioning engineers and technicians struggling due to traffic conditions or network traffic problems where the points on the graphics or on the dashboard that you guys are creating on the supervisor would not be updating to their vision well, where there is very sluggish response from the graphics when you're trying to see a live data in the particular equipment or the systems that you're trying to commission. Now, this happens because if you're directly bringing your BACnet controllers to the supervisors, you're creating all the points, and this is where BACnet tuning policies come in handy, and I'm going to show you how to mitigate these traffic issues and have a healthy system which is responsive on your graphics. Let's dive into it. So I have a station created just for the sake of it as BACnet tuning. I'm gonna do everything from scratch so that you guys know how it is done to bring in or build a database and then discover all the devices and whatnot. So I'm gonna set up my laptop to a good instance where I can discover the devices. I'm gonna have to set up my network as well. Team kit. I'm gonna enable this. Alright. So I'm going to discover a device here, and I specifically want to show you here discovering a device because every often you don't see your devices getting discovered for numerous reasons. The other way around for this is you could literally create a device if you know your instance of the device and then the IP of the device, like I'm putting it right now. So as you can see, once I include it manually, you'll still see the status being okay. So it is talking to the device here. So I'm gonna discover all the points. I have 79 objects, but I don't need all 79. I need all the analog values, analog inputs, analog outputs, binary inputs. So as you can see here, while I'm trying to bring this into the database, you see something called tuning policy name over here. So if you can see here as well, there's a tuning policy name which is to default policy as of now. So we'll dive into this and I'll let you know what it is and what it should be based on it. Enable all my binary outputs. Alright, so I have 30 objects in my database. You see all the tuning policy names. So in default view, while you discover your points and bring it to the database, you don't see it. There's a tiny icon here which is really handy. So if you click on this, it will show what else do you want to show in the columns here in your view. So if I deselect this, this is how your default is going to look. So I have enabled the tuning policy type here so that you actually see what are the tuning policies we have. Now right beside the tuning policy you see something called read, and which says poll. What this essentially means is the 30 objects you have in your database gets polled. Polled meaning these 30 objects sends out a request to your controller saying, or 30 packets sending out saying, hey, I need the current value that you're reading at this current instance. And this poll of how and when it should be sending out is defined under these policies of default policy. So if you have a default policy and it is set up to say 10 seconds, every 10 seconds there would be 30 packets going out asking or requesting what is your current value, what are you reading right now, so that I can refresh it or update it in your graphics or the supervisor here. So every 10 seconds it starts reflecting here whenever it gets a poll back from the device. Now consider this just being 30. Now consider you have a 10,000 points worth of a facility you're doing this. Now every 10 seconds you're sending out 10,000 points or packets back and to and from your supervisor to your controller, where there is a tree architecture from all the controllers going to one network switch and all the network switch going to another network switch and that network switch coming back to your supervisor. You see where there would be a choke in this architecture where you're sending 10,000 packets every 10 seconds. Now, what is recommended in this scenario is you have analog inputs, analog outputs, analog values, binary inputs, binary outputs. Say in the analog inputs, you have temperature sensor, humidity sensor, pressure sensor. Analog outputs, you have your speed signal, which is to be shown of what the VFD is doing, what your valves are doing. And then there are analog variables, which might be a few constants to run your PID, few constants which you're using for your internal program, where there is no change as such. So, and in the binary input, binary output, binary values, these are digital zeros and ones. It might not keep changing every often, but let's say you have a binary input which is a smoke alarm. You don't want your smoke alarm to show up on your graphics after the smoke is activated at your controller, but your graphic shows maybe 10 seconds, 15 seconds later. You don't want that. This has to be fast pollen. Now, to mitigate this, what I'm going to do is maybe for the temperature sensor, which is not a very fast responsive or responding variable, every like any temperature variable of the equipment is seeing, it doesn't like ramp up or ramp down to like 5 degrees below, 10 degrees below, or at least a degree below, not in a brisk time of it. It takes a couple of minutes. As compared to pressure, every second there would be a decimal change. Or let's say you have a dead end, you don't have any of your valves open, but you're shooting your pumps to go to certain hertz. You will create the pressure. That is a very fast fluctuating variable, which needs to be very fast responsive to your graphics as well. Now, what we're going to do is, apart from the default policy, if you go here to your tuning policies under BACnet network, you could create another policy. I'm going to say this as fast. You could create another policy. I'm going to say this as slow. What I'll do is, if you see the default policy here, the polling frequency of this is normal. Fast, the polling frequency of this is or will be fast. I'm gonna change the same way as slow of the polling frequency to slow. Now I can go back to my points here, and let's say I want all my binary inputs, outputs, all of these to be fast. So I can go back here, and then I can go back to edit. I'll say all of this to be fast. So I could do all of these. Now I'll go back to these one, edit. I'll make all these to slow. Now all my analogs are slow, all my binaries are fast. Now, What is fast, slow, or default? Who sets this up? For to answer that, if you go to, I want to say network here. If you go to your network here, you see something called pole frequency, pole enabled. You see something here which says fast rate, normal rate, slow rate. So what this means right now is this has been set up. So fast rate has been set up to 1 second, normal has been set up to 5 seconds, slow has been set up to 30 seconds. So the points which we have configured as slow right now only polls every 30 seconds. The normal ones were polling every 5 seconds. The fast is going to poll every second right now. So the ones which you see here, this is a very important parameter that you want to see. Busy time 0%. In a bigger margin of a site, you will see this thing raking up to 90-95%, which is very bad health on the network. This usually I personally try to maintain this thing below 70 or max of 70, somewhere there. If it is going above 70, I'll have to think of what I'm doing wrong. The ones which you see here are the fast poles, the normal poles, and the slow poles. This will give you how much percentage of points are fast poled, how many percentage of points are normal poled, and slow pole. Here. So I'm gonna show you this thing real quick. If I go back to my device again, I'm gonna go back to the points. Let's say I select all of these, edit, go back to this, and say all of you become fast polling. When I come back to my poll service, you see these numbers would be changing after every poll, and you'll see these percentage changing. You see this? Your normal polls are getting down 44, and your fast polls are getting up 51. So it usually or drags the whole normal polls over here and brings it over here to the fast poll. So this is what gives you how much of a time or how much of the percentage of your overall system is doing fast, normal, or slow. How to define these numbers? My trick to these numbers is, if you consider 1 second, 5 second, and 30 second, what happens here is when this fast poll of 1 second goes to, like, let's say this is the first, I'm gonna show you with the quick demonstration. So let's say I'm gonna use my pencil. This is your first second, second, third, fourth, fifth. I'm gonna do 6, 7, 8, 9, 10. So you have 5 and 10 as normal. But you're 1, 2, 3, 4. So this is the first second. You're sending a fast poll in this second as well. The very next second, fast poll again, fast poll again, fast poll again. What happens here in the 5th second is you're sending a normal poll as well, and you're sending a fast poll as well, which creates more traffic. This again repeats at the 10th second. Now, while this happens all the way to the 30th second, what this does in the 30th second is you're sending a fast poll for 30th second. Now, as the 5 multiplies, you're sending a normal poll as well, and at the 30th second, you'll send a soft or slow poll as well, which eventually becomes all of your database points, which are segregated to fast, normal, and poll, going at the 30th second, which will create traffic again. So the way to choose these is by a simple mathematical knowledge, where you would have heard of prime numbers. God damn it. Prime numbers. What this does is, these prime numbers, let's say your 7 will coincide with maybe any other number? No. 11, will it coincide again by multiplying? No. So what we do is, you consider your fast pole at maybe 5 seconds. So I'm gonna do this here. So what you do is, every 5 seconds you'll have your fast pole, and then for the normal pole I'm gonna pick up another prime number. I'm gonna do this 19 seconds. So normal I'm gonna do at 19, but I'm not gonna do 30 because 5 would coincide with the slow rate of 30 at the 6th time. 5, 6, 0, 30. So I'm gonna do maybe 37, so that it has different times. What this does right now is, fast, normal, and slow never coincides with one another. This is how you configure your tuning policies, your polling rates, so that it balances your traffic. Now you see there are fast poles to 80, normal poles to 17. The other thing I want to touch upon here, instead of doing so, this is to one single controller where you're trying to do all the points to fast, all the points to slow, or whichever points you want to do here inside one single device. There is another way where you can do it in bulk, according to Well and Wish of how you want to do this. Now, let's say you want to change the tuning policy of a couple of points in bulk. The one thing which you have to see is, where does the property of tuning policy reside under a point? So you go inside AX property sheet, you see something called, so if this collapses, you see something called proxy extension. You open it, you see tuning policy name. Now, for your program service, which is used for your BACnet, you will need what the parent is to reach to this variable to be changed. What you do is, go to your AX slot sheet, you see something called type. This is important, what you have to observe. So under type, for proxy extension, this is control semicolon abstract proxy extension. So you go to your program service, you go to find objects. I want to say, I'm gonna do the whole overall of BACnet network. I'm gonna say custom. I'm gonna say control abstract proxy extension. So you can define a few, whichever to well and wish of what you need. So I'm gonna say okay. Now, in here by default, you won't see this tuning policy name for all the points, all the 30 objects that I'm trying to create. You right click, select columns. You could enable and disable to what you want to see in the properties of these. So I enable tuning policies. Let's say on all these points, I want to do it in bulk. I'm gonna say I don't need any of these BV points. I'll clear these. Find objects. I'm gonna do this again, and then clear selected items. I just want to do this to all the AIs. Edit slot, tuning policy name. In here, the only thing is you won't see those 3 that we created, the other 2 we created. You will have to manually type this. I'm gonna say if this was fast, I'm gonna do it to slow. If I do this, clear all, find objects, I'm gonna rerun this. You'll see all of my AIs, AVs change to slow, and the other ones are fast. So for doing it in bulk to overall of your network, you can write any BQL that you want to write here to figure out only those points. So what we usually do is consider the whole of BACnet network, and I'm gonna say whichever has the display name or like temp, and then run this. So all the temp points would be, temperature points would be here, and then we're going to change the tuning policies of those to a certain tuning policy that I want to intend to change it. So network polling, you'll see this thing change again according to the fast and slow that we have created over here, which will take time because your slow rate is 37 seconds. So hopefully this helps you in troubleshooting your traffic networks, and then helps you with the fast responsive graphics that you guys have created. Thank you for watching my video. Let me know if you guys want to see something in particular that you want to see. Happy to help. Please drop in the comments that you want to see. We'll go from there. Thank you.